Welcome to another boring webinar about ROS, where we are going. No way, man. No way. This is going to be a boring webinar. It's going to be a funny webinar. We are going to do a lot of practice and we are going to enjoy and learn a lot. So thank you very much, everyone, for waiting for me, for starting here. It's 6 in the afternoon here in Barcelona, Spain, and we are going to start with this webinar about how to build your ROS-based robotics course. That it could be a MOOC, for example, a massive open online course, or it could also be applied to your own course that you can have at your university or school, whatever you want. And then what is my goal with this webinar here? My goal is to show you how you can build, how you can create, and then afterwards deliver this ROS-based robotics course by using free tools. So in this case, I'm not showing you how to use costly tools. So everything that we are going to use is going to be free and you can use over the internet. And what are you going to learn by attending this webinar? So you're going to learn how you can structure your MOOC in the building process, I mean. So how you can structure the construction of your course and how you can build it, of course. Then how you can engage your students in your MOOC by using exercises, of course, that are a specific type of exercises that the students like the most, that is to interact with robots, of course. And then we are going to show you, I'm going to show you how to deliver this MOOC that you have created to the world, because delivering is also a very, very important part of the MOOC, because otherwise it's a dead course if you cannot deliver to the world. Great. Let me tell you that if you stay until the end with me, by the end of this webinar, I will show you how you can do in order to get the bonus. And the bonus contains the slides that you can see here, and also a special PDF a document that contains additional details about how to do this whole process. So it's a more detailed document that contains all the steps that we are going to cover today on the webinar. Great. So what I promise is that if you follow this procedure, you are going to have your MOOC ready in a record time, and that you will have a lot of practice exercises for your students. And if you like, that's an option for you, but if you like, you will not require any installation, if of anything, neither in your place for creating the MOOC, nor on the place of the students. So that's huge, isn't it? Okay, so before we start, let me show you one example of one MOOC that we have collaborated with and that follows this procedure. That's a MOOC that about autonomous mobile robots that was delivered last January, a year. It started a year before now. So it was made by the University Jaume I in Spain, and it enrolled about 500 students. And it was a complete success because the organizers, they didn't expect so many people. Also us, we didn't expect so much people, and we were providing some of the resources for those courses, and we got overwhelmed of that. Then the second edition is going to be this year on March, in case that you want to enroll and then see something that is live that follows this procedure. You have there the link, and then you will have it also the link on the description of the video. And who is this guy who's talking to you? So that's me on the picture. And my name is Ricardo Tellez. I am the CEO of the company, The Construct. That it's a company where we build products. We build actually tools for helping people to learn and program for robots faster. Our goal is to provide some tools that allow the people to make better programs in less time for robots, because that's one of the lacks that robotics has. It's a very complicated science, I would say, and we need the proper tools. By having the proper tools, this can make the difference between succeeding and not succeeding. And that's what we dedicate at Deconstruct. But anyway, let's go with the subject that we like and the reason why we are here. It's a step-by-step guide to build a robotics MOOC. Let me tell you that you are going to need to follow with me the steps. So you are going to practice. I expect that you practice with me the steps that I'm going to do. So we are going to go step by step, one after another. And then have your computer prepare for that. You only need a web browser, just to clarify. So you don't need something special. So probably you are set up because you are watching this webinar. Okay, so first step of the procedure, setting up the environment. What does it mean? Well, it means that before we start creating our MOOC, we have to decide how we are going to, in which environment we are going to integrate our course. What do I mean by environment? I mean, are we going to do videos for YouTube? Are we going to do a course based on videos like the Udacity or Coursera, something like that? Then that's the environment, is the place where the course is going to actually run and the format in which the course is going to run. Then in this case, for the procedure, for the method that we are teaching here, we are not going to use videos unless you want something additional that you can do, of course, but it's not the main thing. The main thing is to use a ROS environment. So our environment for the course is a ROS environment, a running ROS environment. Then we are going to use Jupyter notebooks. If you don't know what are Jupyter notebooks, it's an application, a web application that allows us to embed code with text and with many other things. You will see later on this webinar what are Jupyter notebooks. And then we are going to use Gazebo simulations. This is key for the course, okay? Because this is what is going to allow us to test and to practice, to allow the students to practice with the robots. And then how are we going to provide this environment? Because I mean, that's a complex environment. That's not something that you can go and put a video on YouTube or something and I am done. No, of course. You have to provide the ROS environment, the Jupyter notebooks, the Gazebo simulations, the code, etc. So how do you provide this? You have two options at present. One, either you make the students to install this environment in the computer, in the local computer, or you prepare yourself a virtual machine with all that already installed, or a Docker machine with everything already in place that you have to build this. That's an option. Or you can use the ROS Development Studio, which is an online system that provides all that environment already off the shelf, just with a web browser, that you don't have to prepare anything of the prior. Okay, I understand that people have some differences in opinion, and then maybe some will like to have the virtual machine or else. Okay, it's okay. The procedure that I'm going to describe afterwards, it's independent of what you do later. But the practice that we are going to do now is going to be with the ROS Development Studio, of course, because it's something that is online and everybody can use right now. The ones that you have attended this webinar, you knew nothing about that, and just came and, hey, I can start working with the ROS Development Studio in 1 minute. And that's why we are going to use our product. It's for free, of course. Then let's go. We have set up the environment. So the first thing that we are going to do is to go to the RDS and create a free account. So go to this address right now, rds.deconstructsim.com, then go there and create a free account on this platform so you can start working. Okay, so I'm going to wait for a couple of minutes until you create this, and just give me an okay if you are on the chat, if you are already done with this. And so I will show you in the meantime. I'm going to show you in the meantime that we wait for those people doing the free account. Let me just show you how does it looks by sharing my screen with you. So let me just change the screen. Okay, so I have to do this, and then that, and then that's it. So basically, it looks like this once you are inside. Okay, so what you are seeing is the inside of the ROS Development Studio, where we are going to create our programs and simulations and the course and the text and everything. Don't worry. So this is basically the environment. We have many tools here for creating our courses and doing experiments, because this platform is not only for creating courses. It's also, we use a lot in order to do experiments with robots or to create programs for real robots also. We have many simulations that are already off the shelf that you can launch it and they work already off the shelf. We are going to use our own simulations, okay? So the 2 minutes have passed, and then somebody is asking if it is a different login than the Ignite Academy. No, it's the same login. So you have a button there where you can log in for the for logging to the ROS Development Studio with the Ignite Academy password. So yes. Okay, so let's move forward, okay? So what do we do now? Let me just close this and go to share again the presentation. Great. So now we are here. So you have created your free account. Great. Now, next step. So first step is step 0, actually. Step 0 is just set up the environment. Step 1, decide the subject that you are going to teach, of course. And it has to be a subject. I mean, you cannot say, hey, I'm going to teach about robotics, because otherwise, if you don't have a clear structure, that's a problem. That's a problem because it starts to become massive. You cannot organize this very well in different units. And then you get lost, and finally, you will not publish your course. And that's not what we want. So decide the subject and decide a programming language. So the programming language is the language in which your students will do the exercises. And if you use ROS, you can use Python or C++, of course, because we are using ROS, okay? So in the case of our course, we are going to create a course along these different steps, okay? So step 0, we created the account. Then on step 1, we create we decide which is the subject. And the subject that we are going to use is, I have some trouble here with my, so for some reason, sorry, my slides got stuck, and I don't know why. I cannot get back, sorry, just a second, I'm going back. Some steps are put forward, and I don't know why, because the CPU load is not high. And okay, we are back to the step 0. Yes, we decided the environment, created the account, and then we move forward to the next one. That is the step 1, to decide the subject and the programming language. For our case, we are going to create a course about robot navigation. For robot navigation, and we are going to teach how to do robot navigation by using ROS. And for the programming language, we are going to use Python, of course, because it's a lot easier. You can use C++ if you want. I don't recommend it, because you will get a lot of time and frustration from the students, because they cannot solve the compilation problems that are not related to the subject of robot navigation. So in our case, we are doing Python just to simplify. And I highly recommend that you start doing this. Okay, so that's our step number 1, decided the subject and the language. Next step, step number 2, let's decide the units of the MOOC. So let's decide which units we are going to include in our MOOC. So you have to just think about, in your case, in our case for robot navigation, we have decided 6 units. 1 is biodometry-based navigation, sensors for robot navigation, And then we start now with the SLAM techniques for building maps and then localizing on those maps at Unit 4. And then finally, on Units 5 and 6, we show how to plan paths and then move along those paths while avoiding the obstacles. Then finally, we end all the courses by a project. That the project is something that the students have to do that integrates the knowledge of all the units. Okay, so I highly recommend you that you do something like that. This is an example. Okay, so now let's go and create the project for the first unit of the course. So our first unit is this one, is odometry-based navigation. So we are going to do this right now here. And everyone that is listening has to do this. So let's go for it. Then, in order to create the project for the first unit, you have to go to the RDS, log in, and then follow my instructions. I'm going to do it for you on the screen at the same time. Okay, so let me just share again my screen. Change from the presentation slides to the RDS screen. And then you don't have this screen yet because I have been entered in the inside, but you have a screen similar to this. Once you log in into the system, you should have something like this. And this, in my case, I have many projects already done. Okay, so you will not have other projects. So this list will be empty. But don't worry. The only thing that you have to do is to create a new project. So let's do that. Let's press the button here. And then here on the name, let's say the unit title, that it's going to be Unit 1, Odometry-based navigation, as we mentioned before, okay? As we mentioned in the slides. And it's a private simulation by now. So yeah, so it's okay. So we say create, success, and then we have it here. Okay, first step done. So we have this project created here, and you should have this project here. Now, okay, so now let's go for the next step. So let me change again to the slides. There. Okay. I see some questions. Sorry, I cannot go to the questions on the chat because too many things at the same time. But I see something about PayPal or something. No, this is free. This is completely free. What you are doing here is completely free, so you don't need to pay anything or else. So in case that is requesting you PayPal, is you selected the wrong option. Just select the free tier. Okay, it's more than enough for what we are explaining here. Great. Let's go for the next step. Next step is step 3. Is to decide which robots to use. So every unit of the course is going to teach a subject, and every subject has to have an associated simulation of a robot for the students to practice and program with. And what we recommend is that you change the simulation for each unit. Maybe you say that's a lot of work. Yes, I agree that it's a lot more of work, but this is for the sake of the understandability of the course, because by using different robots for the same related concepts, the student can see the same concepts once and again from different points of view. And this we have detected that in our courses, that people first likes it a lot more, and second, they make them understand faster the same concepts, because they are seeing this, for example, the common bell topic. So, oh, this is a common bell for a 2 wheels robot. Yeah, but that robot here on the screen, it has 4. It's the same thing. Yes, it's the same thing. It doesn't matter, but the kinematics is a little bit different, but it works the same way. So that's it. Why we suggest that you use different simulations for each one of the units. But it's not possible, no problem. So we have selected for our navigation course the following simulations: the Dartable 3, the Husky, Dartable 2, Jackal, Summit XL. The one on the picture is the Summit XL from Robotics company, RV1. And then for the project, we are repeating the Turtable 2. Okay, yeah, it's okay. Okay, so we make it a little bit easier for the project because the project is more complex. Yeah, okay, no problem. Then just bear in mind that the selected robots for your simulation must be suitable for the subject that you are teaching. In our case, we need robots that can move, that can navigate. But in your case, if you are doing a grasping one, you have to select simulations with a grasper in some way. Then about the simulations. So do you have to build the simulations? No, they are already there on the internet. There are many, many reports, and most of the companies that build the robots, they do provide their simulations. Just in case that you want to download all the simulations that we are showing here, we have in our simulations repo, and you have here the address. So you can go and grab them there in case that you want it. Okay, so let's go and do practice now. We are going to do the first unit. And if you remember, the first unit is about odometry-based navigation. And as I mentioned on the previous slide, for the unit 1, we are going to use the Turtlebot 3 robot. The Turtlebot 3 robot is this one here. It's a robot made by the company Robotics, Korean company. And is this robot here on the slide. And then what we have to do is to clone 3 different repos. Okay, so let me show you how we can do this on the RDS. Okay, so first, let's go and change the screen again for the RDS. Wait, there's too many buttons here to change from one thing to another. Okay, yes, and then I think I have it. Yes, too many screens and too few physical screens and too many windows, I think. Okay, so we are here. So if you remember in the previous step, we created this project here. Now we need to open it. It's inside this project where we are going to put the simulations, the notebooks, the extra code that we'll need. Everything is going to be stored inside this file here. That actually is a project. Then if you click here or open project, then it says whatever, the description. We didn't put any description, that's why it's not showing there. And then we press run. Then after a few seconds, then you will get this screen that says, want to restore? No, because I want to start from scratch. Okay, so we have this screen that I previously showed you before. Then we have to do is to install these simulations in this project, the project that we have open here. For that, let's open a shell. Okay, first a shell. Yeah, let's start by doing this. So if we open a shell and we do here an ls, you will see that you have 3 different workspaces: the Catkin workspace, the notebooks workspace, and the simulation workspace. Great. We have to go and install the simulation in the simulation workspace, of course. So we go to simulation workspace and then the source. And here we are going to do the 3 gits. You can see the git instructions in the video. So if you are on the screen you are watching this webinar, of course, then beneath the video that you are watching, there are the 3 gits that I'm going to do right now. So they are there. You can copy and paste from there. So let me just do it myself. Oh, yep, I forgot to git clone. Yes, so I have a problem here. What's the problem? It's yeah, okay, yeah. So it's because I want to go fast and then clone. Yeah, here it's 1. Then I'm going to get the second one here. And I'm going to, in the meantime, yeah, so I'm going to open the 3rd one here. and git clone. Okay, that's the biggest one. So that's the one that is going to take longer. And it's downloading the whole things that the simulation needs in order to execute. Then after that, we are going to compile it, and then we are going to launch it. And you will see that it's there. Okay, so we have cloned this, and all that the things that we have cloned, it's inside our project. Current project, Unit 1, odometry-based navigation. So this is already there. Oh, great. So we are advancing. Now, we need to compile for that. If you know ROS, you know that you have to go one directory down and then cat key make. So let's compile this. Oh, sorry. Yes, now. Oh, okay. So I don't know why it's doing this. Yeah. Okay. Yeah. Some strange side effects. Here it's almost compiled. And we are about to launch the simulation. One, everything is compiled. And you will see that it's very simple to launch it. So as you can see, this is an example, a live example that we are doing directly right now with data that is not our own. It's the data from another company. It's from Robotics. Okay, finish the compilation. Now let's go and launch it. How do we launch this? Then we have to go here to simulations. And then we have a list here of simulations that are already provided by the ROS Development Studio. So you can just click and then it will launch the simulation for those robots, Fetch Robot, BBA Divo, autonomous vehicle, Husky, whatever. But we want to launch our simulation from the simulation workspace. So we need to select a launch file for this. So I press here, select launch file, and then it appears this box. But this is not the launch file, because the simulation contains a lot of launch files, as you can see here, a lot of launch files. Then the one that we want to select is this one, Turtlebots 3 _wall launch. So you select this one, and that's it. We press launch. Oh, sorry, no, still not. Sorry, I have a mistake, because in this simulation, so I'm going to cancel now. This simulation, it's requesting a parameter in the launch file, and we are not providing any parameter yet from the automatic launch. So we cannot provide that parameter to the robot. So what we are going to do is just to modify the launch file. It's a very simple modification. How do we modify this? The code is here, as you can see here in the directory. Simulation workspace / source. We have all the simulations there, but we are not going to use this. We are going to use another tool here that is the code editor. It's the IDE that is integrated into the ROS Development Studio. And then, so I'm going to select here from the 3 workspaces, the simulation workspace already selected, okay? And then I'm going here, coming to the source, and you can see the same information that is here in the here. You can see here, okay? So this is what we have downloaded, we have cloned. It's here on the source, simulation workspace, Then, where is this Gazebo? It's the simulation, sorry, is a key. It's here. So Turtlebot 3 Gazebo first. In the source, you go to Turtlebot 3 simulations, then you go to Turtlebot 3 Gazebo, and here in the launch file, let's open here, let's select the Turtlebot 3 wall launch. Okay, great. Then here we have to provide an environment variable that's still not possible to be done using the ROS Development Studio. No worries, will be solved in the close future. We only have to provide burger or waffle, depending on the 2 modalities that this robot can be shown on the simulation. Let's select, for example, the burger. And then I press here save or Control S, and then my file is saved. Now that I have done this modification, I can launch the simulation. How do I launch it? By coming here, as I explained before, simulations, select launch file. Then here, launch file, I select the Turtlebot 3 Gazebo. Go to the Turtlebot 3 wall, launch, and then press launch. Great. So what happened? A new Gazebo window has appeared here and is showing the whole process of loading the simulation. And then in a few seconds, let me put it bigger. In a few seconds, this is going to show the simulation. And here it is. We have it. This is the simulation log. We can hide it for later. And the robot, if I'm not wrong, it should be around here. Here it is, the robot. And here it is, the whole environment that we are going to use for our navigation course with Turtlebot 3 in the odometry only navigation. Okay, so far so good. I could not follow your comments, so I hope that you are progressing. And then what we are going to do is to switch back again to follow the next steps of the presentation. So I'm going to change from here to the slides. There it is. And now you can follow with the next steps. Okay, so let's go for that. Next step, step 4, is to create the notebook. So by now, what do we have? We have the structure of chapters. We have started with chapter 1, the unit 1, we'll call it units, and we have included the simulation for that unit. Now let's include the notebook for that unit. And how do we do that? By using the Jupyter notebooks. The Jupyter notebooks, you can see something here on the image on the right-hand side. Then it's amazing because it's a web platform that you can embed text explanations with Python code and shell code, Linux shell code. You can embed videos, you can embed pictures, you can even interact from the Python notebook. This one, you can interact in real time with the simulation. So you can post here results obtained directly from the simulation and act accordingly. So that's what we are going to use that in the project in order to create the material that will provide the explanations to the students. So how do we do this? The RDS. Let's build a notebook, okay? So for that, we have to do several things, okay? I'm going to explain first, and then we are going to do it together. First, we are going to download an example unit that I have already created. It's the notebook that I have created for unit 1. I have already created because otherwise it will take us for ages to type everything. How can you download this example? Is if you go to in the webinar, then beneath the webinar, there is a link beneath the webinar that says example of package with ROS code for the course. Okay, so if you go there to that link beneath the video on the related links section, the last link, it says example of package with ROS code for the course. Then you click on there, and then you will receive this package. It's the TarGZ package containing this notebook, okay? So just download this. I'm downloading it right now. And then the next thing is we are going to upload this code into the RDS, into the unit that we are building. And we are going to upload it to the notebook workspace. And then finally, we are going to extract and open this notebook. So those are the steps that we are going to do right now. Okay, so first, go to the video beneath and then press on the link, and then automatically the notebook will download for you. Now, let me change to the other window. So I'm going to change to my RDS. Here I am. Okay, so now what I'm going to do is to upload the file that I have downloaded from the video link. And for that, I'm going to use the IDE that I have here. So in case that you get lost with the windows, you can always press this button here, and then it shows all the windows that you have launched, and you can go back again. It's like the Linux desktop Unity environment, so it's something similar. So you can change by doing this, or it works like a normal desktop. Okay, great. So how do we upload this file into the notebooks workspace? Well, the first thing is that we have to select the notebooks workspace. So I select this, and then here I already have it. So press right click on the directory where I want to upload. That is the notebooks workspace. Right click and then upload files. Upload files. Then I go and here click to upload, and I don't know where I have put my package. So I don't know where I have downloaded. So I have to look for it. I'm looking for it. Here it is. And then I press open and it's uploaded. Okay, so I'm going to close it now. So here it is, the tar.gz, okay? But this tar.gz has to be uncompressed first. So for that, I'm going to change here to my terminal. You can open another terminal if you want. For example, let's open another one. So we have that in the simulations workspace, and this other one on the notebooks workspace, for example. So I'm going to go to the notebook workspace, and here I have my tar.gz package, and then I do the command for decompressing. The command is tar with the following parameters: x, v, f, z, p, and then the name of the file. You put this here, and then it uncompresses. Great, we got it, uncompress. And what do we have here? So I'm going to refresh this directory by pressing right click and then rescan. And we have here we should have here. Okay, so yeah, sorry, I pressed the wrong, yeah, so I uploaded the wrong file. This is the second file, so I have to delete this. I'm going to delete, sorry, I'm going to do the same procedure again because I have done it rolling with the wrong file. I have downloaded the one that is not there. So I'm going to go back here. Notebook example for download. I press this link instead of this one. So I'm going to do again, press this, save, then come here, and then press upload files and upload this geometry paste navigation. Okay, open. Okay, sorry for this confusion. I apologize if you got confused by that. So this is the other file that we'll have to upload in the next step. So don't worry about that. So odometry-based navigation is here. So in that case, in order to uncompress this file, instead of doing the tar, we have to do an unzip. And I think it was here, yes. So unzip, odometry, yeah. And here it is, we got it. Now I can refresh this, rescan, and here we have the odometry, the unit 1 odometry, and another directory called IMG that contains some files, some images for the notebook. So I'm going to delete this one, the zip file, because we don't need it anymore. Delete, great. And now we have that. So now we have to open this notebook that we have uploaded. So how do we do that then? You come here to the tools, Jupyter Notebook, and we open a new screen, opens, and we have here the files included here in the notebook workspace, of course. And this is an empty one for default that you can use for creating your own notebooks, but this is the one that I have created. You can open that one. So I'm going to open, click, and let me make it bigger. Sorry. Yes. Great. So here we have our unit, says unit 2 is unit 1, but we can change it just as quick as this. Great. So this is the notebook that we have with a lot of explanation, images, exercises, and figures and examples. Okay, so you can have a look afterwards about that. The only thing that I wanted to explain you is what you can see or you can put into a notebook in order to create a rich, very rich content for your students. So what you can do is, of course, you can put text that you do a double click and then it will open. And then when you press Shift Enter, then it renders in the proper way. And you can use explanations, separations, different types of headers, and you can include Python code. And also by using this specific Python code, you can embed YouTube videos, for example. In this case, I have embedded a YouTube video explaining the different concepts of odometry-based navigation. And in order to execute that, just select the cell, you see it selected, and then press play or Shift Enter. And then the video renders here. You can execute, of course, and you will see a demonstration. So the students can do that while using your notebook. I'm going to stop. And also you can include images, and you can include specific commands that you would like them to execute. So they can copy this and then copy this and then execute on the shell. For example, let's copy that one that is more interesting, that is about publishing here on the common bell topic. So it should make the robot move. Let me put the simulation here and let's see how the robot moves. So but I have to complete still the message, twist, and then specify speed. So I'm going to specify a speed for moving forward, not very fast. Let's say 0.2. So I'm going to press this, and then the robot should move. There it is. Okay, so I'm going to stop it by pressing a 0. And this command was obtained from the Jupyter notebook here. Also, you can do online execution of commands if you put this parameter here before, this exclamation mark. And then just how do you do? Just select the cell and then press play. And then we get an echo of the odometry topic directly obtained from the simulation. And you can do even more. So I can edit here and say, okay, so I'm going to call this a Python variable that is called odom. And then afterwards, I'm going to print odom. So I can re-execute the same cell, and you'll see that we get a different output, of course, because it's printing the whole message. Okay, so it's not an echo of the data, but this is the message. And you can play with this and obtain this and process and then generate an image based on what the robot is watching, etc., etc. The different options are infinite. So, so we have now how you can create the notebook is by just typing here, and it's your imagination and you're willing to explain in some way or another. But the options that you have are amazing. You can use this as a template and have some ideas about how you can do some things for your own course. Okay, so we have almost everything done for the first unit. Almost. Let me just change again to the slides. So I'm going to change to the slides. And let's move to the next step. And the next step is to provide some example code to the students, because maybe the students, they follow the explanations, but at the point of creating a whole application for the robot that does a slam, maybe they have a trouble because it's difficult. So maybe you would like to provide kind of template or an example so they can use it and start building from that example. So what we suggest is that you add this code to the unit so the user can use it as a template. And that's what we are going to do right now on the RDS. So I have created a code that acts as a template for doing odometry-based navigation, and that you can download the example from this link. The link is basically that link that you can see on the slides is the webinar. So beneath, there is this link that I misused priorly, or the prior step, is the example of package with ROS code for the course. So that's the link that you have to press, and then when tar.gz file will download, and I have done that, then you will have to upload this file in the same way, but now we are going to upload it into the Catkin workspace source workspace. And that workspace and the Catkin workspace is the one that is going to contain the code that the student is going to generate for integrating for interacting with the simulation. So as you can see, now you have the full picture that we have everything separated in different workspaces, one for the simulations, one for the notebooks, and another one for the code that the student will have to do, or for templates that you would like to provide to the student. Okay, so let's do that. Those steps are loaded, then extract, and then launch the code so we can see what it does. It's a very simple one. Okay, so I'm going to change again to the ROS Development Studio. Let me change this to share the other way around. It's this one. Okay, here is the notebook, and I'm going to close the notebook already because we don't need it. Now, what I'm going to do is to select the IDE and go to the Catkin workspace. Select the Catkin workspace, then I go to the source, and here I'm going to press right-click and then upload files here. Now I'm going to upload the file that I have just downloaded from the link on the webinar video. Open, it has uploaded, okay, close, and here it is, T3 basics. So now I'm going to use one of the shells that I have open here, for example, this one. Okay, that was publishing still. Yeah, so I am on the simulation workspace, but this is not where I have uploaded the file, so I have to go one down and go to the Catkin workspace source. And here is the basics, so I'm going to uncompress it. 3 basics. The parameters again is tar x v f z p, and then the code. So far so good. So we have it here. Then let me show you here. Okay, it has created another Catkin workspace. That doesn't matter because it's just a matter of directories and a source. It's because of the way I compressed previously. No problems. This is completely correct. And here in T3, we have on source, we have our basics. It's just a program that we provide to the students so they can learn how to subscribe to the odometry and print it using a callback, and how they can publish into the common bell and make the robot move. So the robot is going to move doing a small circle. Okay, it is. So this is a very short example that you can analyze later. I have put a lot of comments. And the thing that we are going to do is just to launch, because it's a Python code, we don't need to compile. So it's ROS run, and the package is called T3 basics. And the program is called basics.py. And wait, we have to check the simulation because we have to see how the robot is doing exactly here, the small circle. Okay, So this is the execution of this package. Okay, great, great. So almost done. Then I'm going to close this. I hope that you have been following everything. Now let's go for almost finishing this. That is, let me share again the slides. So finally, we have included the code for the student, and then it remains step 6. Wait, I have a problem with my slides. I don't know why it's kind of stuck. Sorry for that. Yeah. Okay, so now is step 6, that is to continue the same procedure with the next unit. So we have done everything for the unit number 1, that is basic robot navigation with odometry only. And we have created the simulation, we have created the notebook, and we have created some code organized in a package, and then everything ready for the first unit. So one thing that it remains on the first unit is to save it. So let me just show you how you need to save it. So I'm here on the RDS, and everything that I have included in the different workspaces. This is the Catkin one, the notebooks, the simulation, everything is there. That one I can delete because I don't need any more, the TarGZ. And everything is included there. So how do we save this as a package? Just press the button here. Press the button, say, hey, this project, let's save it. It's a project in RDS. And then it will save everything. Yes, override, because we have created empty project before, so we need to override the empty one. And now it's saving the project. Once everything is saved, you have in that project everything your student will need in order to learn this unit. And the only thing that you have to do now is to repeat the same process. So project saved successfully, and where it is. Okay, how can I see my projects? Where are? So just press this icon here about the wall, and then it will bring you back to your list of projects. And here is our saved project. Okay, that's still running. This one is still running. So you can press here, or in case that you have others, you can change to other projects by clicking on them. I'm going to return to our one. Okay. So yes, I want to restore. Great. And then what else? So now you have to repeat this for all the units. Let me switch back to the slides. Slides is here. Yeah. So you repeat the whole cycle for all the rest of the units. And I recommend that you use a different project in RDS or whatever the tool that you use for each unit, because otherwise it becomes a mess with the different simulations, the different code, the different notebooks. By doing a project for each unit, you get everything separated and very clear when you have to modify something. Okay, so you repeat this and imagine that you already have everything. The next step is to share this with your students. So you have to pack everything and then share with your students. And now you have 3 options. If you have been using RDS, you have 3 options. And one is to download and provide the different projects with installs. You can download from the RDS everything that you have created, everything. So you download it and then you provide with your virtual machine, with your whatever, the Docker or local installation. Then another thing that you can do is to share what you have done inside the RDS. This is very simple. Let me show you. It's very simple. It's here. If you go to the units, the project window, clicking here on the icon. So here you have a button that says share. And in this share, you can type here the username of any of the other users that are in RDS. So your students must be, of course, a user of the RDS. And then you type just here the emails, for example, tellyes@work@gmail.com. And then you just share. I don't remember if I have a user with this. Yeah. Okay. So now it's sharing. Sorry, yeah, I don't have this. This is not my user, my second user. But anyway, so it detects that it doesn't exist. So you can put here as many of them as you want, and then share. And the whole project will be automatically shared with your students here. So that's another option. Another option that you still have is to, let me go back to the slides, is to publish it in our Robot Ignite Academy. We have an academy, if you don't know, that is called Robot Ignite Academy. And then there we provide complete courses for programming robots. And we use this method here, of course. And people can just access to the course. They don't have to do anything in configuration or selecting project. These are courses that are distributed there. And they just log into the Robot Ignite Academy and they click on the course. Those are 3 courses that we have, but we have many, many others in different subjects. And they click there and then they start learning. They start with the notebook already open, the simulation that corresponds, switching between units, everything is implemented there already. So you can do that also in case that you want to win some money. So if you want to send us your courses to this email, maybe you can make a deal and then you can publish your courses in our academy and win some money. So just to let you know, in our academy, until the end of this week, we have a 10% discount if you use this live 212 coupon when enrolling the system. Just to let you know. Now, that's finished the presentation. And how can you get the bonus? So in order to get the bonus, that are the slides and the PDF with more detailed information, just send me an email to this address here on the screen with that specific subject. Please put this in the subject, because otherwise it gets very confusing to find the people who is interested. We receive many, many, many mails, and unless it's organized in some way, we cannot answer the people. So please send me this if you are interested on the bonuses. And now I'm finished and it's time for questions. I have 2 minutes for the questions. I'm sorry, it took me more time than expected because of the confusion and something, but it's okay. So I will have 2 questions. And then if you have more questions, send me that by email. If you still are very, very interested and have many questions, maybe we can arrange a hangout, a personal hangout, and then discuss about the subject. Okay, so let me just see if there are any questions on the chat, and let me see. Okay, so you can post any question there. Okay. So yeah, I see here the first question that I see here is from Epson Warco. I keep getting an invalid path after uploading T3. Any explanations? Okay, no explanation. Sorry with that. I cannot tell you because many, many things. It's I see that here that you are using a tar minus XVZF file name. That's not the, I don't know if that works, but that's not how ion compress. How ion compress is by tar XBFZP file name. Just that, just like that. Then John Vacom says, is there a Spanish version? Not yet. There is no Spanish version yet. And it's only in English, sorry. And any other question? Any other question? So I'm checking here. And then what is a good way to get it in touch, I presume that you mean, Yusef, with you, Ricardo. Yeah, you got my email there. Just send me an email. That's the best way. John Bacon says, should I mount the course on my own site or where the course is mounted? Yeah, no, you can mount the course in the own platform. So I show you I provided you already with the course, with the notebook already made, but I made it using this platform just some days ago while I was preparing this webinar. And it's exactly where I prepare it there, because you can test, you can do many tests with the simulation, with the shells. Everything is integrated with ROS, and you can just create there and then download at any moment in case that you need it to put in another computer. But basically, you don't even need it. If you work with people that is on the RDS, you can share that directly. As I mentioned, as I shown you in the share button. Then I have another question. Sanyam Bhutani says, I want to blog about this. Should I mention the construct of Robot Ignite Academy? Okay, you should not do anything. So you want to blog, your blog is yours. So you can do whatever you want to blog. Then I would really feel good if you can mention us, our company, or Robot Ignite Academy, because we are doing a lot of work and providing this for free. Everybody can use it, the knowledge there. So it will be really appreciated if you can mention us. But you are not obliged, and we are not going to say anything about it. So it's your blog. You do whatever you want. Epson Warco says, is there a limit in terms of a space on the development studio? Yes, there is a limit. I don't remember exactly now the limit, but at present, there is 1 gigabyte for your staff. And so we have more professional versions of the ROS Development Studio that contain a lot more of memory, cores, CUDA, etc. But this free version contains, I mean, you can do everything with that unless you need a specific setups. So try it and let me know if you reach the limit, and we'll see what we can do. Other than making MOOCs with RES, can we use it on any machine connected to Wi-Fi and other hardware like Kinect? Yes, of course. Of course, you can use this for developing your ROS programs with any robot. That's it. We use it for building programs for real robots. And we test here, and then afterwards we connect with the real robot and we execute the program in there. Okay. Sayam says, I want to credit about the company. Which name should I mention? Then it depends on what you want to mention. So if you are mentioning about the company that has built all this, is the construct. If you want to talk about the specific academy that is providing courses, already made courses, ready to use, it's the Robot Ignite Academy. Sayam, last question. Do you think ROS has a good scope with deep learning? Yes, we are preparing a course also based on that, on deep learning. And of course, ROS and the mixture of ROS and deep learning, that's going to be great. It's going to be, I mean, very enriching, because we'll be able to use deep learning off the shelf with robots. This is still very immature situation, but we are moving on that direction, and it's going to be great, I think, because it will open this to many people. Yes, gracias. Okay. Thank you, Sayam. Thank you very much. Yeah, it was a bit fast, Jan. I'm sorry. I thought that was step by step, but in any case, you can re-watch this webinar at any point in time. You also send me the email and you will receive the slides and the additional information, and then you will be able to reproduce exactly. So we took a lot of time in preparing this so that it will work for everybody if you follow the steps. And then that's it. Please rewatch it again and see if it works. If it doesn't, send me an email. I'll be happy to answer you. And thank you very much for attending the webinar. I have to leave right now. It's been really a pleasure. And tomorrow, let me tell you that tomorrow we have a live show where we are going to show how to do navigation using April tags and with a robot. It's a real problem from somebody else. And then if you like this, I would suggest you that you subscribe to our channel, because we are publishing new videos about ROS every day. And if you want to be notified, press the bell. So you have to subscribe and press the bell. And you will be notified every time that we publish a new video that contains answers to questions, very short videos we publish every day of 10 minutes around, and could be of your interest. Thank you very much to everyone for saying thanks. Everyone, Jan, John, Epson, for your suggestions. Thank you very much, everyone. And see you on the next, Matt Drotter, also see you on the next video tomorrow on the live show. Cheers, mates.